Good morning. Hi. So, welcome. Oh, that's really loud. Welcome to my talk today on Now TV and linear streaming and some of the challenges that we faced around getting linear streams to consumers in large quantities. So, first, a little introduction. Myself, I'm Tom Moore. I'm software architect at Now TV. I was previously the senior developer on the team since the project started back in 2012. I've also previously worked in the defense and telecoms industries, and my details are on the screen there should anyone want to get in touch afterwards. So today I'm going to talk a little bit about Now TV initially, just introduce the product, the customer base, and our architecture. We're going to have a look at some of the challenges that we face with linear streaming. We'll take a look at what happened on the 7th of April 2014 and why it happened. I'll go through some of the fixes and improvements that we made to our platform, and then in contrast, we'll take a look at what happened on the 13th of April 2015, and then also cover some of our future work and next steps. So, Now TV. Now TV is the online no-contract service from Sky. It's available across a wide range of devices, including our own Now TV box. Now TV's always had really aggressive ambitions. So we launched back in July 2012 with just a movies proposition, and that was only 6 months after we first started the project. Then in March 2013, we went ahead and launched our sports offering. In July of that same year, we launched our Now TV box, which is that little white box at the bottom there. And in October 2013, we launched our entertainment proposition. And Now TV's been really successful. So year on year, we've had really good growth. Our customer base tripled up to April 2014. And that brings its own challenges, as most people are probably aware. We have to focus on the scalability and resiliency of our system, as well as focusing on the product roadmap and all of the feature sets that the business want to bring in. So Now TV has a really unique set of challenges. If we compare ourselves to some of our competitors or similar services in the market, no one else offers the same combination of VOD and linear DRM-protected streaming and enforcing concurrency limits as well. And no other UK OTT provider offers that same combination. So we really do have a unique set of challenges when it comes to scaling up our platform. So to help you understand a little bit more, here's a really simplistic view of the Now TV architecture. It's basically split into two halves. On the left side is the Now TV platform, and that's primarily what I'll be talking about today. And on the right-hand side is the stream, transcoding, and upload stack. So that's the stack responsible for actually getting the videos up onto a CDN so that users can start to consume them. So just to give a quick summary of platform then, we've got, in front of platform, we use Akamai as a CDN. It offers our SSL termination. We use it for caching some of our content catalog and also for some security features as well. We then have load balancers that distribute the load across our horizontally scalable applications. Our two main applications are content and services. So our content application supports content discovery. So being able to pull up content, search for it, filter it. That is a Groovy application that serves JSON and XML RESTful APIs. It's heavily cacheable because it's just content metadata, and it's backed by a Mongo database. The services application there, that supports all of the user services such as authentication, entitlement checking, purchase, and playout. So that, again, is another Groovy application. It's JSON, XML, REST APIs, and again, backed by another Mongo database. Over on the right-hand side, the upload and availability of the video chunks is all handled by that stack. So the videos come in to our video asset store, and they get transcoded and then uploaded to the CDN, and the CDN then propagates those down to the edge servers for all of our user base to pull off really quickly. Sign in to playout is very load intensive on the Now TV platform. So before you've actually started a stream, in order to authenticate and for us to check entitlement and for you to purchase anything and to actually initiate that stream is really, really intensive on the left-hand side. Once that stream has started, all of your video chunks are being pulled from the CDN on the right-hand side. So it's really important that the Now TV platform on the left-hand side can scale when we've got large numbers of users coming onto the service. Once the video is playing out and the video chunks are being pulled from the right-hand side, the user device makes occasional calls back to platform just to tell us that that device is still playing out, and we call those heartbeats, and I'll go into that a little bit more later on. So now we know the architecture, let's take a look at what we actually do. So video on demand is not a new concept. Everyone's familiar with it, being able to consume video content as and when users want it. Typically, the load for a VOD platform is very predictable. Just ask any of the big players in the market. You get this is a typical week in May of this year across Now TV in terms of our VOD load. And as you can see, it follows the same curve day in, day out. It's quite quiet in the mornings, starts to ramp up over sort of lunchtime, starts getting really busy in the afternoon as kids start coming home from school, ramps up to about 9 p.m. at peak, where people sit down in the evenings to watch some content, and then it quite quickly drops off into the early hours of the morning. So the load there is driven by time of day. Even weekend load, if we look over on the right-hand side there, although those curves are a little bit fatter because of more consumption during the day, it's still a very predictable graph. So if you're able to predict what your load's going to be, then that's great, and you can do all sorts of things like auto-scale predictively. That allows for sort of easy preparations, easy scaling, easy alerting, so you know what your system should be expecting at what time of day. Simple. Linear streaming, on the other hand, unlike other OTT providers, Now TV offers linear streaming, so we stream like TV channels and sporting events. This is typically far less predictable. We've got two graphs here. On the left-hand side is a typical linear load. On the right-hand side is a typical VOD load, both at the same time of day, between 3 p.m. and 4 p.m. The VOD load, as you can see, is relatively flat. The linear load has this nice spike. So this was a football match that kicked off at about 4 p.m. So you see this flurry of people coming onto the service to play out that match, and then once it started, that starts to drop off again. So with this in mind, let's take a look at what happened on the 7th of April, 2014. So Game of Thrones, the biggest show to hit the small screen across the UK, the US, and around the world. The popular fantasy drama came to Now TV in the form of the Season 4 premiere at 9 p.m. on the 7th of April 2014. And I'm sorry to say that we were caught a little off guard. Up till about 8:53, we had normal platform stability. Everything was great. The next 4 minutes, things started to slow down. We saw increased response times, isolated failures. And then by about 8:57, so 3 minutes before it was due to start, the system was completely unresponsive. No new streams could be initiated, existing streams were terminated, and we had some pretty negative sentiment ripple across Twitter pretty quickly. So suffice to say, our users were not best pleased. Any users trying to watch Game of Thrones or other entertainment or movies or sports, anything, it affected the entire platform. We should give some credit to a few of our customers that did come up with some quite creative tweets. One customer in particular even went as far as making a commemorative T-shirt that you could purchase. You could actually purchase a Game of Thrones T-shirt featuring our error message just below it at the time, which was, "Oops, something went wrong here, please come back later." It was also available as a baby grow in case you wanted to put your little ones in one as well. So, and to this day, our head of technology still wears one of these T-shirts. He bought one of these, and he wears it on every single Game of Thrones night. Not sure whether that's a good luck charm or just a reminder of where we've come from, but... And it wasn't just Twitter that picked up on our outage. It was also picked up on a lot of online news sites, including Digital Spy and CNET, and other high-profile news organizations as well, including the BBC and Telegraph. It didn't help that one day before, HBO Go in the States had the same problem. They had Game of Thrones come onto their service, and it took them down as well. So that didn't help the visibility of our issues, as it appeared that apparently no one could handle Game of Thrones. So why didn't we see this coming? How could we have missed this? Well, Now TV is a market that's rapidly growing. Sorry, just adjusting something on my screen. It's rapidly growing and shifting all the time, and keeping up with that pace has been really difficult. We've had to be building lots of new features, and we made some assumptions around what our linear load profile looks like, and it was wrong for Game of Thrones. I'll try and explain. So the load profile we've got here is a football match. The kickoff was at 3 p.m., and at 2 p.m., a sort of warm-up show started. So that was when people started to tune in to see the football pundits start talking about the match before it actually kicked off. So we get this double spike where people The really keen people come on an hour before the kickoff. Other people come in just before it kicks off, and then you can see it quickly dies away over on the right-hand side. So the load of everyone coming on to watch that football match is distributed. It's been spread out over just over an hour. So everyone coming on to watch that match has come on over an hour. Game of Thrones, on the other hand, looks more like that. So that's everyone trying to come on in the space of sort of 5, maybe 10 minutes. Because there's no pre-event build-up, there's nothing for people to tune into beforehand, so they come in for the episode itself, and we get a curve that looks like that. So we saw about 80% of everyone who wanted to watch Game of Thrones tune in within about 5 minutes. That load really condensed, and we saw concurrency leap by 2.5 times. Now, concurrency is the number of currently playing streams across our entire platform, so the number of streams that are currently streaming right now. The peak of concurrency was 50% higher than any previous linear event that we'd had before. Now, sports was always a big deal across Now TV. We may have struggled with sports in the past. So to get an event that suddenly came in with a much more condensed low profile that was 50% higher than any previous linear event was quite significant. And if we take a look at that peak load, it's approximately 100 times the load that we saw maybe sort of half an hour ago or so. So that's a real concern there. So what exactly happened? Well, very high load stressed our database. We saw queues and we saw timeouts. And then what did users do when they saw error messages? They just went retry. And of course, that just compounds the issue, and our load just flew up even further. In terms of issues that were actually observed, new streams couldn't be started. Existing streams were kicked off, despite the video still remaining highly available on that CDN over on the right-hand side of that architecture diagram. We saw concurrency errors, and I'll go into that in a little more detail, and we kept seeing those even after about 10 minutes. The queues across Mongo, the read and write queues across Mongo were getting very, very high, and we also saw some very poor performance across some particular APIs, including our entitlement and view history APIs. We also saw that Mongo was spending a very long time maintaining indexes, and that wasn't great. So after a bit of analysis, looking into our logs and into New Relic and Mongo, we formed a list of issues that we were wanting to address. So firstly, heartbeating was not resilient to platform unavailability. So that was the reason why existing streams were terminated, because those streams tried to heartbeat back to our platform, and we were down, and it ended up terminating that stream. Concurrency checking was liable to inaccuracies as well. Entitlement checking was far too frequent. The way in which we were storing users' products that they purchased was incredibly inefficient, and as was fetching the viewing history out of our database. And then also the indexes that we were using in Mongo were less than ideal, shall we say. And also Mongo's got some quirks around write locks. And I'll go into detail about all of these as we go through. So just to give a brief introduction, another introduction to heartbeating, as you see, if you've got a player there happily playing out, it's pulling video chunks down from the CDN, which is from the stack over on the right-hand side of the architecture diagram. And every 10 minutes, it sends a heartbeat back to Now TV platform to tell us that that stream is still operating. Now, we use these heartbeats to enforce concurrency, so we know how many streams a single user is playing out. We use it to enforce entitlement, to tear down a stream if the user is no longer entitled to be streaming. And we also use it to record bookmark positions if the user is watching a piece of VOD content so that they can come back and restore from that same position. So previously, and at the time of a Game of Thrones outage, if a non-OK heartbeat response was received by the player, it would terminate. So here's a player happily playing along. It sends a heartbeat request into Now TV. If Now TV is unavailable for any particular reason, if that response is anything but an OK, it terminated the stream and it pulled the stream down. This was really very much failing in favor of Now TV. So we were basically averting any risk that we were exposing our content to anyone who was no longer entitled to watch it. We were being overly cautious when there were unknowns in the system, and that wasn't very friendly to our customers. So we turned that on its head. And today, playout will continue unless a specific stop event is received for a limited period. So now, if the platform is unavailable, unless we can tell the device that it should stop it will keep going. So that way, these users wouldn't be affected if our platform went down and they weren't able to heartbeat anymore. One of the other quirks that we saw with heartbeating is because a heartbeat was occurring every 10 minutes, and we had that sudden spike of load come in at just before 9 o'clock, we then saw this kind of ripple effect of heartbeating every 10 minutes after that point. Now, while it wasn't causing us any issues, obviously if we can flatten that load, make it and even it out, it'll be a lot better. So in future, we're looking at randomizing that first heartbeat time, just telling the players that they should heartbeat some point between 1 minute and 10 minutes just to try and even that out. So that was a quick look at heartbeating. Let's take a look at concurrency. So concurrency, as I mentioned earlier, is the concept of how many streams you are currently playing out. Now TV has a limit of 2 concurrent streams per user, and we manage those through the concept of playout slots. So on the left-hand side there is a document representing a particular user's playout slots. When one of the user's devices comes in and they hit play, the platform will have a look at what slots are available, it will allocate a slot, and then it will allow the device to play out. Similarly, for a second device, it will allocate a slot, allow it to play out, but then if a third one comes in and attempts play out, there's no available slots left, so we reject that play out, therefore enforcing the 2 concurrency rule. Now, slots are maintained on heartbeats, so every time we get a heartbeat, we update the timestamp to make sure that those slots are kept fresh. And the reason for that is that any slot that hasn't been updated recently, we deem to be stale, and we tear it down. Slots are also released on an end event. So with that first player over on the right-hand side, happily playing out at the moment, when the user presses stop and the playout stops, the device sends an end event to platform, and our platform pulls down that playout slot from our database. And that now means that if that third device wanted to try and play out again, we can happily allocate a new slot and it can play out. Now, previously, and at the time of the Game of Thrones issues, if we didn't receive that end event, the playout slot wasn't released until after that timeout that I just mentioned. So if an app were to crash, for example, that app on the top right, say it had a power failure or, I don't know, the user lost Wi-Fi connectivity and it died, the first thing a user would do is probably plug it back in again and hit play again. But when that was attempted, our platform went, no, you're already streaming 2 streams. We don't allow you to play out. And that's obviously pretty frustrating from a user's point of view. And it was a lot of issues that we saw. We saw a lot of these issues during Game of Thrones because we were not receiving those end events or players were not sending them to us. So we were getting an inconsistency between what we thought the current streams were and what the actual streams really were. So today we've implemented the concept of playout slot reclaim. So basically we've now allocated a slot to a particular device. And if that particular device crashes, when it comes back to our system, we can tell that there's a slot already allocated to that device, so we reclaim it. We assign it a new ID, update the heartbeat time, and update the content ID, and then we allow that device to play out. So that's basically solving the concurrency limit reached errors that I mentioned earlier on. That was a really quick flyby of concurrency. If we take a look at entitlements. So to consume content across Now TV, customers must be entitled. And this is done through the concept of tags. When you purchase a product has certain tags associated to it, and when you're watching a piece of content, that piece of content has certain tags associated to it. And you need an intersection of the tags between the content and the products that you've got such that you're entitled to watch that piece of content. So for this particular user, he's got a day pass and an entertainment pass, and that gives him a sports tag and an entertainment tag. If he tries to watch a sports stream, he can happily play out. If he tries to watch Game of Thrones, as long as it's not in April 2014, then he can happily play out entertainment. And if he wants to watch a Sky Movies channel because it's got the movies tag, we say, no, you haven't got the appropriate product. So fairly straightforward. Previously, entitlement was checked on every single piece of content on every single piece of content. So when you were browsing the app and flicking from page to page, from movie to movie or show to show, every time we were showing you show details pages, the app was making a call back to our platform to do that entitlement check for that specific piece of content. And that meant 2 database queries on the back end. Every single one of those requests that came back resulted in looking up the content tags for that piece of content and also looking up the product tags for all the products that the user had purchased. Now, at least one of those was unnecessary. The content tags almost never changed. So we realized that we'd built an entitlement system that was far more flexible than it really needed to be. We didn't have this really dynamic concept of different tags on every different piece of content. It was quite generically grouped together. All the movies were tagged with movies. All the entertainment content had the same tags as well. So we introduced checking by tag instead. So now when the app launches up and you go into the movies section, we make a single call and we say, does this user have entitlement to watch movies? Yes or no. And then we know for the entire app, experience within that movies section of the app, but we can tell the user that they can play out rather than trying to encourage them to purchase instead. So this meant that we didn't have to do a content tag lookup at all, and it was far fewer requests, so we were seeing a massive drop-off of requests coming back to our platform. And where checking by content is still required, then those content tags are now cached in memory, so we don't have to go back to the database every time. So that reduced load on our database and also between our 2 applications internally as well. So this works because our tags are segregated and our content is quite clearly defined in different tag groups. But it would be different if it was much more granular. If different movies were part of different groups of products or were granted by different products, then it wouldn't really work in the same way. Now, for entitlement checking to work, you obviously need the products that the users purchased. So we looked at making improvements there too. Previously, when a user purchased or updated, or one of their products renewed, so if it was a subscription, it renewed month by month, then we'd create a new entity in the database. So if this user purchases an entertainment month pass, we'd create an entity in the database. If it renewed, we created another entity in the database. When they bought a sports pass, we created a new entity. When it renewed, we created another one. Maybe they like us so much they sign up to movies as well, and so on and so forth. And as you can see, that list is growing pretty quickly. Now, the vast majority of it is historical data and doesn't really represent the user's current entitlements. It was originally built that way because we had requirements in the early days for reporting and business intelligence reasons to capture as much data as possible. But those requirements have since moved out of our platform and they're handled by different systems. So we could definitely improve that. So now we store the concept of entitlements instead of a concept of products. So now when a entertainment month pass renews, it just updates that same entitlement record. It doesn't create a new one in the database anymore. Different products still create different entitlements, but when they renew, they just overwrite the previous one. Like so. So obvious gains there. Reduction in entities means much less data, means much faster queries, much cheaper storage. Now, another reduction we made in database entities was around view history, or viewing history. So if anyone's used Now TV, you'll be familiar with the My TV section. Got a screenshot from the iOS app over on the right-hand side there. Now that's built up from what we call view history entities, or from a view history, effectively. So when you watch a piece of VOD content, we create a view history in the database. And when you're heartbeating through a piece of VOD content, we also store a bookmark. And for legacy reasons, the viewing history items and the bookmarks were stored separately in the database. Now, that was because in the early days there was this dream that Now TV would have multiple users per account, and the requirements were that the viewing history would be at the account level, whereas bookmarks would be at a user level. So they were separated in the database as 2 different stores. But that was pretty inefficient. We also had no cap or archiving of the data at all. So by the time Game of Thrones 2014 rolled around, we'd been running for almost 2 years, and we had 2 years worth of viewing history there, which was getting pretty significantly large. And that was for the same reason again. They wanted to be able to report and run business intelligence scenarios over that data. So let's take a little closer look at that My TV view. In order to render that view, we had to make a query to our viewings database to fetch the viewings. So here this user's got three things that they've watched. Now for every one of those, we were then going to our bookmarks entity and fetching a bookmark for each one. So we were ending up with n+1 Mongo database calls to render that single view. Now, you might be looking at those n queries and thinking, why couldn't that just be one further query? And yeah, you're right, we did the same. It was an obvious inefficiency in our code, but we went one step further than that. The requirement to support the multiple users per account feature was no longer apparent. So we looked to merge the data. We basically took those viewings and bookmarks, merged them together into a single entity. Now, this brought lots of benefits. In the viewings and bookmarks entities, the IDs were assigned by Mongo because we weren't giving them a primary key. So the ID fields were being created and stored, and the indexes were being maintained for a field which we weren't reading at all. Again, not very efficient. So over on the view history side, when we created that entity, we used a much more efficient ID. We had a compound ID over at the account ID and the content ID. After all, that is the primary key of these records. But we went one step even further than that. So in relational databases, column names are part of a table. In document-based databases, the field names are part of the documents. So they get replicated in every document that's stored on the disk. So if you've got really long and complicated document names, that's obviously going to take up loads of space on the disk. So we shrunk those names down. Instead of account ID, down to AID, instead of content ID, CID. It saved a massive amount of storage over our entire set of data. And it also meant that they were still readable, they were still understandable. We also added an archiving scheme so that any data that was no longer recent or relevant was archived off. So we were now only storing 30 days worth of data rather than 2 years worth of data. So now that we'd made those efficiency in terms of disk space, we then had a look at the actual indexing of these records as well. So during Game of Thrones, Mongo was spending a very long time maintaining its indexes. Now, if you're not familiar with Mongo, when it builds its indexes, it effectively duplicates data. It takes the fields that you want to index, so in this instance we're indexing the _ID field and the account ID field, and it duplicates that data and stores it again. And we actually had 4 different indexes across our viewing entity. That first one, the _ID one, that is a Mongo-generated index. It's not removable, and as I mentioned just now, we weren't actually using that data. So straight away, that was an index that was being built and maintained that we just weren't using. It's a similar story over on the bookmark side as well. Again, an index that we weren't using. So you can see that the indexes can quickly get larger than the actual data set. The size of our indexes in these collections were enormous, far, far bigger than the actual data set. And Mongo works best when you can fit all of the indexes into memory. So this was getting crazy. We were having to add obscene amounts of memory to our servers to be able to store these indexes. So when we went to a single view history entity, we could make improvements in indexes as well. Mongo gave us the _ID index for free, and that's much more useful now because we're using it to store our account ID and our content ID. And then we just had to add one more index to allow us to search by time. So we'd gone from 2 entities down to 1 entity. We'd gone from maintaining 6 indexes down to 2 indexes. So obviously far lower memory requirements, and the reads and writes were far, far quicker. One other inefficiency that we highlighted with Mongo, which was quite surprising, was around write locks. Now, if you're not familiar with Mongo, your data is stored in a document. A document is part of a collection is part of a database, and a database is part of a Mongo instance. Now, obviously, you'll have multiple documents per collection, multiple collections per database, and even multiple databases per instance. Now, previously, a write lock in Mongo was global. So if you were wanting to update one of the documents over in collection 4 on the right-hand side, it wouldn't lock the document that you were writing. It wouldn't lock the collection. It wouldn't even lock that database. It locked the entire instance, and not just for writes, but for reads as well. So while you were updating something over in collection 4, you couldn't even read from collection 1 on the left-hand side. And that's because Mongo was assuring consistent reads for us. So that's obviously not great. So shortly after Game of Thrones, Mongo 2.2 was released, and they had changed the write lock rules. So instead of it being at instance level, they'd now brought it down to database level. I don't know why they didn't go further than that. It seems a bit strange. But so this was better, and we could definitely use that. But it was still slowing us down. It still meant that when we were updating that document over in collection 4, we still couldn't read. We couldn't even read from collection 3. So we pretty much did this. We highlighted our most used collections, and we just separated them off into separate databases so that when you were writing to them, it was only locking that collection effectively rather than locking the entire database. So it's better. It's still not ideal. As of March this year, Mongo released version 3. That comes with 2 different storage engines. One of those offers collection level locking, so it would only lock collection 4 in that example. And the other actually offers document level locking, which would be far better, where it only locks the document that you're currently writing. So that's definitely something that we'll be looking at in future to get a lot more throughput and capacity through our database. So with all of these improvements under our belts, we needed to baseline the platform capacity ready for the Game of Thrones Season 5 premiere that was coming in April 2015. So we did some stress testing with a blend of traffic profiles, including the traffic that we saw during Game of Thrones 2014, including that really aggressive ramp up and that spike that we saw. If we plot the Game of Thrones 2014 load on the graph there, our capacity tests were pretty successful. We managed to achieve a capacity of over 4 times the Game of Thrones load that we'd seen just 1 year earlier. And that gave us real confidence in our platform as a whole and also in our own improvements and in our abilities to find them, I guess. It was also reassuring because in the year between Game of Thrones 2014 and Game of Thrones 2015, our customer base tripled yet again. But despite this phenomenal growth, thankfully the forecasted load was within our platform capacity, which was a good sign. So, enter Game of Thrones again. Season 5 premiere. Hit Now TV at 9 PM on the 13th of April 2015. And it was probably more exciting for us than it was for our actual customers. It was a real moment of truth for our platform that had come so far. And how exactly did we do? We handled it without a hitch. We saw load that was 2.5 times higher than what we'd seen 1 year earlier. The concurrency overall was twice what we normally see on a Monday night. And to help put the load in perspective, here's a typical weekday load for linear playout. If it's no big event, you tend to get these little peaks at sort of on the hour when programs start, as people tend to tune in to watch slightly smaller shows. Now, to get the peak into this graph, I have to zoom out slightly. It's quite large. Again, it was around 100 times the average weeknight load at peak. And this time, the sentiment across Twitter was a little more positive, shall we say. Customers actually acknowledged the issues that we'd had a year earlier, and they were actively congratulating us and saying well done for fixing it and turning around our fortunes. And it was a really wonderful sentiment that these people had actually stuck with us. They hadn't been put off by from what happened a year earlier. So were there any issues? There was one minor issue. #buffering boobs, aka boobgate by some of our creative customers. Approximately 45 minutes into the episode, we started noticing this same frame appearing on people's tweets. And it was closely followed by a second peak of playout initiations on our platform. Now what had happened is there was a bug in our propagation servers on the CDN, and they were pushing chunks of video down to the edge nodes, and those chunks had a content length header that didn't match the actual packet size. So when the devices were pulling down these chunks, they were reading the content length header and trying to read the packet, and the packet was too short. And some of these players were not resilient enough to be able to handle that. The frame that you see on the screen there just happened to be the last frame in one of these truncated packets. So some devices didn't handle this very well. Users had to back out and reinitiate the stream, which is why we saw the second peak of playout initiation shortly after we started seeing all of this appearing on Twitter. It didn't affect everyone. It was a small number of users affected, and it has been fixed. We've made some improvements in our CDN propagation, and also built resiliency into clients so that they should be able to handle these missing or truncated truncated chunks. But buffering boobs aside, the remainder of the season went through with a great success. No further issues. We had the final episode on Monday night, and I'm pleased to say that it was a great success. We've been recognized a couple of times over the last month or two. The first by MongoDB. We've worked really closely with them, as I'm sure you can imagine, over the last year, improving our database. So yeah, they awarded us for all of the work that we've done around improving the database performance. some of which I've talked about today, and there was far more, a bit too much that I probably shouldn't go into. And then also we got an award from the Digital TV Group, and they were recognising innovation across the whole of Now TV, so that's including the product offering, the Now TV box, all of our apps and services. So it's really great to actually get that recognition for the hard work and for the achievements that we've made. So next for Now TV, well, we achieved a lot over the last 14 months. Game of Thrones was a great success, but we shouldn't get complacent. Our growth is on the same trajectory as it has been, so we're expecting very high loads next year, and obviously we've got some ambitious performance numbers to meet. We're also looking to move to an active data center to help to spread our load, to lower some of the latency costs between our users and the data centers, and also to build in some resiliency in terms of losing an entire data center or an entire data link. We're also looking at potentially overflowing into the cloud. So as you can see, that peak that was 100 times our load, it seems crazy to have a system, a platform that has a capacity of that peak for 100% of the time when we only need it for less than maybe 1% of the time. So how can we overflow into the cloud? So when we know when we know Game of Thrones is coming on, how can we overflow and start scaling up our system in preparation for that peak and then tear it down shortly afterwards? But there's a question about how we can actually trigger that, because it's linear events, it's not triggered by time of day. So there's probably going to have to be some manual intervention. We're probably going to have someone press a button saying, I know that a peak is coming, scale up. We're also looking at microservices. So the two applications I detailed in my architecture diagram earlier are quite large monolithic applications, and they really do need breaking down. So we're starting to break those down into microservices. And that obviously comes with all the benefits of microservices, independent development, independent deployability, and independent scalability as well. So also, Now TV is dependent on lots of both internal and external dependencies inside and outside of Sky. Now, we need to try and make sure that we can ensure an end-to-end functionality, even if one of those dependencies is unavailable. So if we're not able to fetch the latest EPG information, we need to make sure that the user experience isn't ruined too much, and we can still at least allow them to start playing out the stream. Or maybe if we're not able to play out a stream, what can we do instead? How can we still give them as good an experience as possible, rather than just throwing them out and saying, no, it's no good. So we're doing a lot of work around that now as well. So just to say, just some credits. Obviously, all of these achievements were not possible without the whole of the Now TV technology team. That includes all of the platform software engineers and the quality engineers as well, our DevOps engineers who are looking after all of our hardware, the app testers and developers, and also all of the analysts, scrum masters, and management teams around us as well. And also a credit to the whole of the Now TV business for helping to drive our growth. I think that's credit for driving growth. And for repairing the damage that was caused to our brands because of what happened a year earlier. But most importantly, and thanks to anyone in the room who is a customer, thanks for sticking through it with us, and obviously we are pleased that you did. Now TV is growing, and we need more talented people to join us. It's really surprised me the last couple of days, the number of people who've come up to our Sky stand just outside and said, oh, didn't know you do technology. It's amazing. So please come and talk to us, or talk to me after if you'd be interested in joining the team. We've got loads of open vacancies, especially across Now TV at the moment. Just take a look at workforsky.com or come and talk to us. So thank you very much for listening. It's been a pleasure to tell you for the first time all about Now TV, and I'll be happy to take any questions that you might have. Yes? Yeah. We obviously have quite, because we're an online service, so sorry, to answer your Twitter feed question first, we're an online service, so we've got quite a lot of online presence, and we've got whole teams dedicated to making sure that the Now TV brand looks good across social media. So it's those guys who are monitoring it, but then also on big event nights, we were sat in the office with Twitter up as well, just manually monitoring it and taking a look at it. In terms of Splunk, so the sort of metrics that we look at is the number of playouts that we get per second, or the sort of ramp up of playouts. We can also monitor heart beating, as that gives us an indication, a relatively true indication of our concurrency across the entire platform. And then we can also look at just general things like the number of sign-ins, or the number of times that the content catalog is being fetched by devices. So our logging is pretty good now. We've got quite good visibility across all of the different features and services that you can do across Now TV, and yeah, we've got some really good visibility in Splunk. Are there any on the online? Oh, has that worked? Oh, let's just throw that up. Okay, so if you were able to rewrite Now TV from scratch, would you choose MongoDB again or something else? As Mongo stands now with 3.0, it's not bad. It's not as bad as it was a couple of 2-3 years ago. So I probably wouldn't. I'd probably look at Cassandra. But we should acknowledge that they have improved a lot of things, and they are now a much better competitor in terms of database technologies, and we're working closely with them to try and make things even better. It hasn't got bad enough for us to consider a different database provider just yet, but maybe it will one day. What did you use to monitor the system during the crash? What did you use for post-mortem? Yes, so we've got some, just to flick back a slide or two. Sorry, I don't think I highlighted properly in my, oh, come on. No. Behave yourself, come on. In the architecture diagram, which I've now lost. Sorry about this. Yes. So on the left-hand side, we've got some different tools that we use for monitoring alerting across different layers of our system. So for the load balancers and most of the hardware, we use iSinger. Across our applications, we've got our own logs, and all of those logs feed into Splunk. We've also got New Relic that we use, and we're starting to introduce App Dynamics as well. And then at the database level, Mongo have got their own monitoring tool called MMS. So we use that for monitoring Mongo. And that's the tool that told us about things like where Mongo was spending a lot of time building indexes and things like that. What percentage of users had the buffering issue? I think it was about 10%. So it was enough to cause a bit of an outcry on Twitter, but it wasn't as bad as the 100% who were affected a year earlier. So that's still a win, right? What was the first thing you did after the 7th to deal with the load? So the first thing we tried to do was to replicate the problem in our staging environment. Because it came such a shock to us, we had been doing performance testing, and we hadn't seen this problem, so we were like, how has this happened? And it was because of that ramp up, that sheer ramp up that we saw just before 9 o'clock. So the first thing we did was to change our load tests to make sure that ramping up was a lot more aggressive, put it into our staging environment, ran it, and then went, oh yeah, it does fall over, yeah. So once we'd seen that, and we had we'd also done some analysis in terms of our logs and different monitoring tools, we were then able to build up a list of things of issues that we wanted to go away and fix and have a look at. So is your core platform written in Java? So we've got the two big applications that I was talking about today are both Groovy applications, but we tend to use Groovy more for the sort of syntactical sugar on top of Java, rather than, just to remove some boilerplate, rather than using it as a full, sort of in the full Groovy language. And then we do have some smaller projects, some of which are in Java 8, some are in Scala. So it's a bit of a mixture. It's a bit of a mixture. And how did you do your load testing? So we used an IBM tool. I can't remember what it's called offhand, but it generates load for us. Basically, it just throws a load of HTTP RESTful requests at our application in our stage environment, and we scale that up depending upon the load that we're seeing, and then we can sit back and watch our logs and watch New Relic, etc. Yes. Gatling. We did look at Gatling in the early stages of the project a couple of years back, but we didn't really have the time to invest in getting Gatling up to speed, and we also didn't have this sort of Scala skill set that we needed for Gatling. The whole team was hired to come in and do performance testing, and they made decisions around what technologies they wanted to use, and they went with this load testing, Load Runner, that's what it's called. Is it IBM or HP? HP Load Runner, yeah. Yeah, so we used that. Okay. Yes, sometimes. We had to make sure we were happy with all of the changes, obviously. But when we sort of said to them, if we do this, then we won't fall over, they obviously preferred us to make the change. Yeah. The strictest thing we have to be careful of is around content rights. We have some very strict content rights with the studios, and we had to make sure that we weren't in breach of any of those with anything that we were doing. So that was the most difficult thing. Yes, yes, yeah. So,
Did you have any concerns around the CDN's ability to deliver?
we didn't until Boobgate, and then, but they were very good. They jumped on it very quickly, and they had fixed it literally within a week or so. So we've used Akamai for a very long time, and we've got quite a good relationship with them. So at the moment, no. If we were to change anything, it would be Mongo before we change Akamai. But yeah, yeah. So I think that was around using a Google tool to generate to predict the load. Was it trends? I haven't considered that. I haven't seen that actually. Maybe I'll go away and take a look at that. Thanks. Is it one down the front? Yeah.
I noticed in all your pictures you had you often had a picture of the now TV boxes. What does your customers run? What platform?
So the Now TV box is our largest platform. It is approximately 60%, I think, 60 to 70%. And then our next most popular devices, try and get this right, Xbox is up there. Xbox is quite a big one. I can't remember exactly offhand, but yeah, the box is definitely our largest. It's a great little box. It's only £10 to buy in the shop, so obviously people jump on it, and yeah, it's the vast majority of our user base now. Yeah. This year? A lot better, yeah. Same as us, yeah. We should have done actually. We didn't work with HBO actually. But yeah, we both obviously learned our lessons from a year earlier. So, yeah. Yeah.
What changes you made to require one of the two concurrent streams?
Yeah.
I guess comparing the device ID.
Yeah.
Is there any risk that someone can spoof the device ID and essentially for multiple devices tend to be a device ID that's already registered?
In theory, yes, but as soon as the first stream that you played out tries to heartbeat, it's got that playout slot ID, and if that playout slot no longer exists, the heartbeat will fail and the player will tear down the stream. So, in theory, yes, you could get more streams than you're supposed to, but only for a period of one heartbeat, and then when that heartbeat comes in, it will tear the stream down. Yeah. I think it says 3 minutes left. If there's any more questions, or yeah, one more. I think I have to say no comment. I don't think I'm allowed to. I can't speak in terms of sort of propositional type stuff. But
Have you at least considered it?
considered it, yes. Sky would need to go to 4K first before Now TV could. I think that's all I could say. Why was that?
It's just a file downloaded off the internet.
So it's all of our content rights are tied into quality as well. So we don't yet have the 4K rights, and we would need to wait for Sky to negotiate those in order for us to be able to offer higher resolution on Now TV. Yeah.
Joking aside, does that worry you that there's a big jump in quality that add a lot of extra load, or is it just on the CDN side?
It would only be on that right-hand side, yeah, because it would still be the same number of requests, the same amount of traffic on the left-hand side to actually initiate a stream. It's just then the size and the quantity of the chunks on the right-hand side that the player's pulling down from the CDN. So, I mean, Akamai should be worried, but I'm not worried. Yeah. Well, yeah. We have some, a limited amount. We don't have loads of environments that we can use to throw loads and loads of traffic at. So we have a dedicated performance environment, and we run those before we push to production. We always go through a performance test first, but it's not on every build, if that makes sense. Cool. I think, yeah, pretty much time up. So thank you very much.